This week, we're going to wrap up talking about how to combine data frames into larger, more complex data frame structures by talking about merging and joining. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I wanted to show you how to use merges and joins. Now, if you are from the database world, these will sound pretty familiar, and they're very similar to what we do in many SQL database operations. But I thought this graphic that I found online was a really good way to illustrate how some of these merges and joins work. The idea is that we want to take two different data frames, represented by X and Y here, and combine them based on some data that is in both of them. So if we have an inner or a natural join or merge, it's only going to have data that is in both of them, shown by this shaded area. So data that's in X that matches with corresponding data in Y will be merged and returned. Outer has everything, and as you'll see, Pandas will fill in the rest with nans. Left has everything that's in the left side of our merger join, in this case X, plus what overlaps with Y, and right has everything in Y plus what overlaps with X. So that just seems like a lot of words right now until we actually get into it and look at some data. So we'll hop over here to a clean notebook and import Pandas. And I'm going to go over what the difference between merge and join is sort of at the end, but I want to show you them in action first. So I'm going to read in two little sample data files that I've made. Wind 30min.txt and temperatures, which are going to be temps hourly.txt. So you already might see why we can't use concatenate to do what we want to do here, because I've got wind measurements that are taken at 30-minute intervals and temperature measurements that are taken at hourly intervals. And I want to make some data frame that represents all of this data. So let's look at winds and temps. This is roughly what I would expect: 30-minute interval wind speed, wind direction, and hourly interval air and relative humidity. Okay. So let's call a merge on temps and winds and not give it any other arguments. So what do you think the result is going to be? We've got one data frame that has 1, 2, 3, 4, 5 rows, and one data frame that has 3 rows. When we merge those, what do you think the result will be? Well, it's a data frame with 3 rows. So merge, by default, uses what's called an inner join or a natural join. Looking back at our table here, that means it's only the things that are in both X and Y. So it has looked at these two data frames and said, hey, they both have a time column, and they both have 0, they both have 60, and they both have 120. So I'm going to return a new data frame that has those 3 rows and have all 5 variables for those 3 rows. We can specify different kinds of joins if we would like. So I'm going to call pd.merge temps winds. How, I'm going to specify an outer join. So we'll look at our table here. Outer join should give us all data. There are no data points lost when we do this, but we're going to have to do some filling in. So we have all of the time values, though they're out of order in this case. That's not a big deal. We could always sort or maybe make the time column an index. That's probably what I would be doing next. And where we don't have air and relative humidity data, or air temperature and relative humidity data, it just put nans, not a numbers there. So there was no data loss, and it filled in missing data with nan, which seems like a pretty sensible behavior, and that's probably what I would want in this case, is an outer join or outer merge. So let's call merge temps wins how equals left. Let's go look at our picture again. This means everything that's in X and what overlaps with Y. Temps is our left side. So remember the temps were hourly. So it's all of those and what overlaps with Y. In this case, that's going to be the same result as the inner. Now, if there were some things that were in temps that weren't in wins, they would have been preserved here. Now we'll do the last and right merge. Temps wins how equals right. So this should give us everything in the second and what overlaps with the first. So if we had some more columns in our second, we would keep those. We need to have temps. And we do. So we have more columns in our wind speed, or more rows in our wind speed, wind direction. Those are kept and filled in with nans. So that gives us the same result as the outer in this case. So I like looking at these diagrams when I need to put a couple of data frames together and think what operation I really want. Because if you blindly call merge, it's likely that you might be throwing away some data that you didn't mean to because you're doing this inner join by default, not keeping everything and filling in with nans, which is the outer. So refer back to this for sure before you call a merge. Now, I can certainly do this merge based on time. I have done it here. But join is a special function that looks at the indices of the two data frames and joins based on that. And by default, it is a left join. So looking back at our figure, merge by default is an inner join. The join by default is a left join. So I said it would make sense to have the time as an index anyway. So let's go ahead and do that. So wins.setIndex time in place is true. Temps.setIndex time in place is true. If I look at wins, I have that time now being an index. Temps, also it's an index. So now I'm going to call join on one of these data frames. So if I call wins.join temps, I get what I wanted. So I have that index preserved. It's joined based on index, and it's a left join. Since wins has more time indices than temps, it has kept all of those since they're on the left side. If I call temps.join wins, we only keep the indices from the left side temps, unless I were to specify in here how equals right or how equals outer. So this is one of those cases where the order that you call these matters. So wins.join or temps.join produces a different result. I find it very useful to experiment with functions like this with some small fake data sets like this until I really understand what they're doing, so I don't make mistakes when I'm doing my real analysis. So you might say, why would I use join instead of merge all the time? And you certainly could use merge. Sometimes I find the left join type is what I want to do anyway, so I just type this. If I already have the index set, this is a lot less typing, even more so. And really, under the hood, join is calling merge, just with some different defaults. You can look at the documentation for these. There are a lot of options that we didn't go over, including, say, maybe one of my data frames has time as the column name or the data series name, and the other data frame has date time as the name. So you can specify names with left equals, right equals. There are many, many options, but using merges and joins responsibly means there's no looping. I'm not looping over things. I'm not concatenating things. I'm not manually filling in missing data. It results in me writing much less code, much faster code, and code that uses functions that are heavily tested and maintained by the Pandas development team. So I know that I can trust them probably more than something that I whipped up on a Friday afternoon, right? So it's always good to use those tools to your advantage. It's one of the things that makes Python so powerful. I hope that you found this useful, and I'll see you on next week's MetPy Monday.